Today, we're diving deep into the invisible nervous system of your car. Seriously, we're going to talk about the secret language that all the little computers in your vehicle use to talk to each other. A system that has to work perfectly every single second just to keep you safe on the road. So, let's get right into it. So think about this for a second. This isn't some riddle. This is the actual everyday reality for automotive engineers. A modern car has more lines of code than a fighter jet. It is, without a doubt, one of the most complex pieces of technology you will ever own. So finding a single bug in that massive moving web of software, well, that's a ridiculously tough problem. How in the world do they do it?
Well, the answer lies in understanding the car's secret language. And to really get a handle on the problem, you first have to appreciate the sheer scale of what's happening under the hood.
Your car isn't just one computer, not even close. Get this, it's a network of over 150 of them. They're called electronic control units, or ECUs for short. Each one is basically a mini-computer with a super specific job, and they all have to be constantly sending messages back and forth. I mean, just think about it. You've got an ECU managing the engine, another one for the brakes, a totally separate one for the airbags, the radio, even your power steering and the heat. And here's the kicker. All of these separate brains need to communicate perfectly and instantly. But if they're all made by different companies, how do you make sure they're all speaking the same language?
That is exactly where a standard called AUTOSAR comes in. It's the essential blueprint that allows this incredibly complex orchestra of components to actually play in harmony.
The easiest way to think about AUTOSAR is as the master operating system for the entire vehicle. It creates a common framework, a set of rules that every supplier has to follow. And that standardization is the foundation for everything, making sure that a braking system from one company can flawlessly talk to an engine controller from a completely different one. But okay, even with a common language, you still have millions of messages flying around every second. You need a system to manage all that mail. And within the AUTOSAR standard, that system has a name, DLT. To really understand it, let's imagine your car has its own central post office.
So what does DLT stand for? It's Diagnostic Log and Trace. And its whole job, as the official spec says, is to receive all this log information from all the different software parts and make that information visible outside the ECU. It's the bridge, you know. It connects the car's internal chatter to the engineer's diagnostic tools.
Now, this post office handles two basic kinds of mail. First, you have log messages. These are like status updates, a letter that reports a specific event like, warning, brake fluid is low. Then you have trace messages. These are more like shipping manifests, just tracking the constant flow of data like, wheel speed sensor is reporting 55 miles per hour, now 56, now 57. That's the raw data being passed around the car's network.
So the process itself is actually pretty simple, just like a real post office. Step 1, a software component, say the braking system, writes a message. Step 2, the DLT module, our postmaster, receives it. And then, step 3, DLT's most important job begins, sorting. It has to decide what's junk mail and what's an urgent overnight delivery. Finally, it packages up the important stuff and sends it on its way.
Okay, so how does this whole process actually help an engineer? How does a message get from the engine's little computer all the way to a developer's laptop? Well, that sorting process we just mentioned, that is the absolute key.
DLT uses something called a log level to sort all this mail. The AUTOSAR spec defines this as a way to classify how severe a message is. Basically, it's a priority stamp. A message like infotainment system started might get a low priority stamp, but something like airbag sensor fault, yeah, that gets the highest priority stamp possible.
And this right here is why that sorting is so brilliant. On any given drive, your car is generating a massive, overwhelming flood of data. But thanks to this log-level filtering, DLT can be set up to just ignore the 95% of routine, unimportant messages. All that noise gets thrown out. It only passes on that critical 5% that engineers actually need to see, which keeps them from just drowning in useless information.
So, once a message is stamped as important, it gets tossed into a buffer. Think of it as a digital mailbag. The priority stamps tell the system which mail to process first. Finally, DLT hands that mailbag over to another module called the PDU router. And the PDU router? It's the delivery truck. Its only job is to take these packaged data units and send them out over the car's network so they can actually be seen by diagnostic tools.
So, we have this elegant little post office system sorting and delivering messages inside your car. But why does this specific piece of code, buried so deep in your car's software, actually matter to you?
Well, for one, it means faster repairs. When your check engine light comes on, DLT is what lets a mechanic plug in a computer and see the exact error message from the exact component that failed. No more guesswork. Second, it makes our cars safer. By giving engineers a crystal clear view of what the software is doing, they can find and squash critical bugs before they ever become a real problem. And finally, this is the bedrock for the future. You just can't build a reliable self-driving car without a rock-solid diagnostic system that can report its own status with perfect clarity.
When you boil it all down, it comes back to this one simple sentence from the official specification. DLT's whole purpose is to make the internal, invisible state of the car's brain visible. It's all about creating a window into that incredibly complex world so we can understand it, fix it, and ultimately trust it.
And that kind of leads us to a final thought. We've seen how today's cars use this secret language to report on faults and performance, but as we start to hand over more and more control, what new secrets will they need to share with us? What kind of messages will a fully autonomous car need to send for us, as humans, to truly trust it with our lives? Something to think about. Thanks for tuning in.